It arrived unannounced. A cosmic vagabond, streaking through our solar system at speeds that defy comprehension. 209,000 kilometers per hour. Not merely passing through, but tearing through, as if our familiar celestial neighborhood were just a brief rest stop on a journey that began before our sun first ignited. This is 3I Atlas, not a native of our solar system, but a visitor from the interstellar void, a frozen relic cast adrift from some distant star, carrying secrets of alien chemistry and cosmic history in its icy heart. Hubble's piercing gaze has captured it, but not tamed it. The comet remains an enigma, its true size hidden, its origins lost to time. What story does this interstellar wanderer carry? What catastrophic event launched it on its billion-year odyssey? And most haunting of all, how many more like it are sailing unseen through the darkness? The discovery was accidental, as many great discoveries are. The Atlas system, designed to protect Earth from catastrophic impacts, found something far more extraordinary. A faint dot, moving too fast to be bound by our sun's gravity. At first we thought it was a glitch. The trajectory was all wrong. This wasn't just another asteroid, it was something from beyond. Initial calculations sent shockwaves through the astronomical community. This object wasn't merely fast, it was impossibly fast. The numbers didn't lie. 3I Atlas was interstellar, only the third such visitor ever confirmed, following Oumuamua in 2017 and Borisov in 2019. Within days, Hubble was called into action. Its sharp eyes revealed something startling. This wasn't a dead rock, but an active comet. A faint plume of dust streamed from its surface, catching sunlight as it fell behind. The very presence of this activity was a puzzle. After billions of years in the interstellar deep freeze, why was there still volatile material left to vaporize? Astronomy's great eyes all turned to watch. Each new observation raised more questions than answers. This wasn't just a visitor, it was a mystery wrapped in ice, hurtling through our backyard at interstellar speeds. 3I Atlas defied expectations at every turn. Its speed, the fastest natural object ever recorded in our solar system, told a story of cosmic billiards played across galactic timescales. At this velocity, the comet wasn't just passing through. It was barely noticing our sun's gravity, a gravitational hiccup in its eternal journey. The numbers suggest this object has been traveling for billions of years. Each stellar encounter, each molecular cloud passage added energy like cosmic pinballs. The longer it traveled, the faster it went. Then came the size paradox. Hubble's images suggested a nucleus between 320 meters and 5.6 kilometers. Yet it displayed activity typical of much larger comets, like a tiny ice cube producing steam like a boiling lake. Could its chemistry be fundamentally different, formed under alien conditions with volatile ices unknown in our solar system? As Earth's most powerful telescopes turned their gaze toward the interstellar visitor, each new observation peeled back another layer of mystery. The comet's secrets were not given up easily. They had to be wrested from the darkness, photon by precious photon.
The first shock came from Keck spectrometers. The chemical fingerprints in 3I Atlas's coma showed ratios of hydrogen isotopes never seen in solar system comets. This was alien chemistry, water ice forged around another star. Particularly startling was the deuterium to hydrogen ratio, nearly 3 times higher than in any known solar system comet, a clue that this body formed in a much colder environment than our own primordial solar nebula. These measurements are like tasting wine from a vineyard on another world. The isotopic ratios tell us about the temperature and density of the cloud where this comet was born, and it was nothing like our own. Webb's infrared eyes revealed even stranger secrets. Hidden in the comet's outgassing were complex organic molecules, not just simple ices, but chains of carbon compounds that should have been destroyed by billions of years of cosmic radiation. How had these delicate molecules survived? Perhaps shielded deep in the ice, only now being exposed? Or could some unknown chemistry have formed them during the long interstellar journey? Most puzzling of all were the radar reflections. The signal bounced back with unusual intensity variations, as if the nucleus wasn't a simple ice ball, but had an irregular structure. Fractured terrain, underground cavities. The data teased but didn't reveal. Each new dataset raised more questions than answers. This wasn't just an interstellar visitor. It was a catalog of anomalies wrapped in a riddle, and time was running out. As 3I/Atlas sped away, astronomers raced against the fading light. Every observation might be the last. Every photon might carry the crucial clue. The window to understand this messenger from the stars was closing, and some secrets might escape forever into the dark. Just when astronomers thought they understood this interstellar vagabond, 3I/Atlas began behaving strangely. Not with the predictable outgassing of a typical comet, but in violent, inexplicable bursts, as if something beneath its icy surface was fighting to get out. On November 12, 2025, the Neil Gehrels Swift Observatory detected something extraordinary, a flare in ultraviolet light that briefly made the comet 50 times brighter. Lasting just 36 hours, the eruption spewed over 10,000 tons of material into space. Dr. Dennis Bodowitz, Auburn University. We've seen cometary outbursts before, but never with this violence from such a small body. This wasn't just ice sublimating, it was detonating. The most perplexing part, the temperature was wrong. UV spectra showed gas heating to 1,200 degrees Celsius, far hotter than sunlight alone could explain. Then came the rotation mystery. As astronomers tracked brightness variations, they expected the regular pulsing of a spinning nucleus. Instead, they found chaos. Dr. Marco Michelli, ESA NEO-CC. It's not just tumbling, it's tumbling violently. The rotation period changes by hours day to day. We think the outbursts are literally kicking the nucleus like cosmic thrusters. This explained the unpredictable flares. Sunlight hitting newly exposed ice pockets as the nucleus erratically rotated.
Most startling was the March 2026 discovery, a faint cloud of debris trailing the comet. Not dust, but something darker. Dr. Jane Liu, MIT. The spectra match complex organics, tholins like those on Pluto. But how did they survive interstellar space? Unless this was never a single object. We may be seeing the remnants of a catastrophic breakup. Two bodies that spent billions of years together before a violent separation. Then came the true shock. As 3I/Atlas departed, it wasn't slowing as expected. Precise Doppler measurements showed a tiny but undeniable extra push, 0.2% faster than gravity alone could explain. Dr. David Farnokia, NASA JPL. At first we thought instrument error, but 4 independent observatories confirmed it. Something is giving this comet an extra kick. The uncomfortable truth? We may be witnessing physics we don't yet understand. A farewell gift from the cosmos. One final mystery as this visitor returns to the void. As 3I/Atlas vanishes forever, it leaves behind more questions than answers. Perhaps that was its purpose. Not to be understood, but to remind us how much we have yet to learn about this strange, beautiful universe. The enigma of 3I/Atlas has forced astronomers to consider explanations ranging from the plausible to the extraordinary. When faced with the impossible, science does not retreat. It reimagines. Each theory is a window into the unknown, a testament to our struggle to comprehend this cosmic anomaly. Far-fetched, perhaps. But in science, we must follow the evidence wherever it leads. And then there are the whispers, the quiet discussions in late-night observatory cafeterias. Could this be something other than natural, even into the darkness? Dr. Jason Wright, Penn State. I'm not saying it's artificial, but if someone wanted to send a probe across interstellar space, disguising it as a comet would be brilliant. The ice shields against radiation. The outgassing provides propulsion. And who would question a wandering iceberg? The truth, we may never know. But the mere possibility forces us to confront profound questions about our place in the cosmos. In the end, these are not just theories about a single anomalous object. They are stress tests for our understanding of the universe itself. Each possibility, no matter how improbable, reminds us how much we have yet to learn. 3I Atlas is gone now, but its legacy endures. A cosmic riddle that expanded our imagination even as it escaped our grasp. As 3I Atlas fades into the interstellar dark, astronomers worldwide are preparing for the next act in this cosmic drama. New tools, more powerful than ever before, stand ready to hunt for other interstellar visitors, and perhaps finally solve the mysteries this first messenger left behind. Scheduled for launch in 2029, ESA's Comet interceptor represents a revolution in cosmic preparedness. Parked at the L2 Lagrange point, it will wait patiently, for years if necessary, until another interstellar visitor is detected. Dr. Michael Kuppers, ESA project scientist, wait patiently, for years if necessary, until another interstellar visitor is detected, then race to meet it. Dr. Michael Kuppers, ESA Pro 3I Atlas taught us we need to be ready. The next one could appear at any moment, and we'll have just months to react. This time, we intend to get a close-up view. When the Vera C. Rubin Observatory comes online in 2025, it will transform the hunt for interstellar interlopers. Its 15-terabyte nightly data harvest could detect dozens more visitors like 3I Atlas. If they're out there, Dr. Lynn Jones, Rubin's survey strategy team, will scan the entire visible sky every 3 nights down to 24th magnitude. Nothing moving faster than 0.5 arcseconds per minute will escape our notice, perfect for catching these high-velocity visitors. Even as 3I Atlas disappears, scientists are performing what amounts to a cosmic autopsy. The ALMA array in Chile now tracks microscopic dust particles left in the comet's wake, searching for isotopic fingerprints. Dr. Karen Oberg, Harvard Center for Astrophysics. These dust motes are time capsules. Each one may contain preserved samples of chemistry from another star system, if we can catch them before they're gone. In a bold, interdisciplinary move, particle physicists have joined the hunt. The same detectors designed to catch elusive dark matter particles are now searching for evidence of 3I Atlas's mysterious acceleration mechanism. Dr. Elena Aprile, Columbia University. If dark matter interactions caused those velocity anomalies, we might see similar signatures here. It's a long shot, but worth checking. Most ambitious of all is Breakthrough Starshot's new proposal to launch gram-scale nanoprobes at 20% light speed, capable of overtaking objects like 3I Atlas within years rather than centuries. Professor Abraham Loeb, Harvard. The technology isn't ready yet, but within a decade, perhaps. Imagine catching up to one of these visitors and flying alongside it as it leaves our system. 3I Atlas was just the beginning. The universe has thrown down its gauntlet, and across the globe, a new generation of scientists and engineers are rising to meet the challenge. For the first time in history, we stand ready, not just as passive observers of interstellar visitors, but as active participants in the greatest detective story the cosmos has ever written. In the end, what lingers is not just the scientific mystery, but what this fleeting encounter says about our place in the cosmos. For a brief moment, the universe sent us a postcard from places we may never see, and in doing so, changed how we see ourselves. For millennia, comets were seen as divine messengers, omens written in fire across the night sky. Today, we know them as something perhaps more profound, the first tangible evidence that we are not alone in the universe. Dr. Jill Tarter, SETI Institute. Not alone in the sense of other civilizations, though that may yet come, but alone in the sense that our solar system is just one of countless others, each with its own stories written in ice and dust. 3I Atlas showed us the fragile nature of cosmic existence. This visitor survived billions of years in the interstellar void, only to begin disintegrating the moment it entered our solar system. Dr. Carl Murray, Queen Mary University. We're watching entropy in action. This object may have formed around a star that died before our sun was born. Its very presence here is a miracle of celestial mechanics, and its disappearance a reminder that nothing lasts forever. In 1990, Voyager taught us humility with a single pixel that was Earth. Now, 3i Atlas offers a new perspective. That pixel could just as easily have been a visitor from another star. Professor Brian Cox, University of Manchester. This comet didn't care about our telescopes or our theories. It followed laws of physics written in the first moments of the universe, indifferent to whether anyone would ever notice its passing. Perhaps the most profound lesson is that the universe is constantly sending us messages, not in radio waves or laser pulses, but in the chemistry of ancient ice, the dynamics of hyperbolic orbits, the whisper of escaping gases. Dr. Natalie Battaglia, UC Santa Cruz. We thought we'd find life's precursors in exoplanet atmospheres. Instead, the universe delivered them to our doorstep on a frozen shard from another star. In a universe of hundreds of billions of galaxies, each with hundreds of billions of stars, this one small comet has given us something priceless. The certainty that we live in an interconnected cosmos, where the stuff of other worlds routinely visits our own. T Atlas is gone now, but its legacy remains, not just in our data archives, but in our collective imagination. It has shown us that we are not just observers of the universe, but participants in a grand cosmic exchange that began with the first stars and will continue long after our sun has faded. Somewhere out there, the next messenger is coming. Another frozen traveler from the interstellar dark, carrying new secrets in its icy heart. The question is no longer if we'll find it, but when. When Rubin achieves first light next year, astronomers predict it could find up to 5 interstellar visitors annually, each one a new chapter in our understanding of galactic planet formation. Dr. Michelle Bannister, University of Canterbury. We're about to transition from seeing these objects as rare curiosities to recognizing them as a constant population, the cosmic detritus drifting between stars. With each new visitor, we'll expand our dictionary of cosmic chemistry. The molecular fingerprints in their ices will tell stories about thousands of alien nurseries. Dr. Stephanie Milam, NASA GSFC. Imagine comparing notes from comets born around red dwarfs versus blue giants. We're about to gain our first true comparative planetology of the galaxy. And then there's the question no one dares say too loudly. What if one of these objects isn't natural? With Rubin's sensitivity, we'll finally have statistics to confront the possibility head-on. Dr. Andrew Simeon, Breakthrough Listen. We're not saying it's aliens, but if someone wanted to send a probe, camouflaging it as an interstellar comet would be brilliant. Now for the first time, we'll have enough samples to test that idea properly. The story 3i Atlas began doesn't end with its departure. It lives on in every new eye we train on the sky, in every young mind that looks up and wonders what else might be sailing unseen through the cosmic night. We stand at the threshold of a new era, one where interstellar visitors become ordinary, yet never lose their power to astonish. For in their frozen hearts, they carry the most precious gift the universe can offer. The certainty that we are part of something vast, strange, and beautiful beyond imagining.